Hi everyone, it's Orkan. Today we are going to solve a problem when we are given an array and we need to find a subarray that is mountain subarray, mountain array. So what's the mountain array means? Mountain array means that, for example, in this case, we are given this array and the mountain array, that mountain subarray in our case, is the subarray that increases up to a certain point. For example, until 7 it increases and then it decreases until another point. So, and in this case, in another example, in this case, the length of our subarray, which is mountain, is equals to 5. We are returning 5. In this case, there is no mountain subarray, so we are returning 0. How we are going to solve this problem? Let's take this example. The way we are going to solve it, we are going to use two pointers approach. We are going to initiate start and end point. And first, we need to start our start, right, for our subarray that is mountain. What's the start? The start is that if our current element is more than our next element, it cannot be our start. So our element should be less than our next element, right? So first we are moving our start here. We moved our start here, and our start now here, the next element is more than that. Okay, it can be our start. Now we are starting to move our end element. So right away, once we find our start, we set our end to equals to our start, and now we started to move our end. So we are moving our end until the next element is more than the current element. So we are moving so 4 is more than 1, we are moving our end here. 7 more than 4, we are moving our end here, and the next element is not. So starting from the next element, so it means that we have a mountain, it has been increasing and now it's decreasing. Let's say that even it breaks here, right? So we have to take that as a one mountain, right? Mountain subarray. So what we are going to do, so we are, okay, now the next element is decreases. We have a max, right? That we initialize initially to 0. Then we are going to update our max as we are going through our array. So for example, at this point, our max is equals to, so the next element, right? Now we are decreasing, it's a mountain, 7, 3 more, less than 7. So our max is equals to 4, right? Then can we consider the next element? Okay, let's check. 2 is less than, so now our end is here. 2 is less than 3, so now we are moving our end here and updating our max, which is equals to 5. How about the next element? No, we cannot consider that because that element is more than our previous element. So our mountain subarray breaks here, which we are taking as the first one, right? So now we are setting our start and end here, and let's say that we have more elements here, and we are going to proceed in our array in the same way that we have done so far. So first we find start, then we go and start our end, and each time we are updating our maximum and returning whatever the maximum is. Okay, first thing, let's initialize our size of our array because we are going to use that a lot. So let's take the array, right, length. Okay, so and the first corner case we can check here, if our n is less than 3, we cannot make the subarray mountain subarray by default, so we are returning 0, right? Okay, now we have this case. Let's initialize our start and our max. So our start is equals to 0, our end also equals to 0, and our int max also equals to 0. Okay, now let's go over our array. So what we are gonna do here, first thing that we are gonna do, let's find our start, right? Let's move until we find our start. To do that, to find our start, so we are moving our array until it's less than n-2. Why we are taking n-2? Because we are checking the element and the element that comes after it, right? That's why we are taking n-2 in order to not to have array out of the boundaries exception. So we are taking n-2, and So now let's find our start. So while our start is less than n minus 1 and our array start, right? Start is more than or equal the same array start plus 1. So we are moving our start until we find the next element. So until we find our start, right? So our next element should be more than our current element in order for us to consider it as a start, right? So until that moment, we are going to increment our start. What's the next? Once we exit this loop, we have our start. Now we can send our end to our start. Our end is equals to our start. Now we are gonna move to our end. First thing, we are gonna move it upwards. So the every element end is also less than n minus 1, right? And so our array, and so it should be next element should be more than the previous element, current element. So our end, and it should be less than our array and plus 1, right? Plus 1. So for this case, what we are doing, we are incrementing our end, right? We are incrementing our end. So if we exit this loop, what it means? It means that we have increased our array. We have not increased our array. We have been, the array has been increasing at that portion, and now it starts to decrease. So now we can increase our end and also at the same time update our maximum, right? So what we are gonna do, we can actually copy paste this part, right? So the next one is we are gonna go until our array, so here we forgot to add bracket, the same here, right? The same here. We are gonna go until our next element is more than our current element. So what's that mean? It means that at that point our mountain array, so that we cannot consider the next element as a part of our mountain subarray, right? So we break at that point. So in each step, as we are progressing, we are gonna update our maximum. So we are gonna take our maximum, right? And we are gonna take either our max, or we are gonna take our end minus our start and the plus 1. Okay, and also once we exit this loop, we can move our start now and go to explore the next mountain subarray. So for that, we are gonna set our start that equals to our end. Okay, and now we can return max here. Okay, let's run it. Okay, let's correct that here. Also, we have extra bracket here and here. Let's run it. Okay, great. It works as expected. So let's calculate our time and space complexity for this solution. What's the time complexity? Time complexity for this solution, since we are going over array only once, our time complexity is n, and we don't use any extra space here. Since we are not using any extra space, our space complexity is constant. Okay, that's it for today. Hope you like my content. If you like it, please hit the like button and subscribe my channel. That's the only way how you can support me. See you next time. Bye.